Hello everyone, welcome back. Guys, topic for the day is Ospf network types. This is very important topic for network engineer. Many time interview is asking multiple questions from this topic in interview. And many of my subscribers were requesting me to make one video on Ospf network types. So today in this video we will discuss each and everything about network types in Ospf. So in this video you will understand when DR and BDR election will happen, when DR BDR election will not happen, in which type of network DR and BDR required, in which type of network DR and BDR not required, right? And as you know, Ospf support two types of neighborship, static neighborship and dynamic neighborship. So in this video we will discuss in which type of network you can configure a static neighborship, in which type of network you will configure dynamic neighborship, where a static neighborship is supportable, where a static neighborship is not supportable. Fine. So in this video we will discuss each and everything about Ospf network types. Just I have one last request that please watch this video till the end if you want to learn everything about Ospf network types. So guys, we have 5 types of network in Ospf. First one is point-to-point network. Point-to-point network. Okay. Second type of network is broadcast. Second type of network is broadcast. Third type of network is non-broadcast. 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 Fourth type of network is point to multipoint. Point to multipoint. And fifth type of network is point to multipoint non-broadcast. Non-broadcast. Okay, and we have two more types of network. First, sixth one is loopback also. Loopback is considered as a network type in Ospf, loopback. And seventh type of network is virtual link. So if you will configure virtual link in Ospf, there will be network type is virtual link. Network type will be virtual link there. So here first we will discuss these 5 types of network. This is very important topic in Ospf. Okay, so guys, first of all understand two topology. See, in GNS3 I have designed two topology. Here two routers are directly connected with one serial link, and here two routers are directly connected with Ethernet link. So as you know, here DR and BDR election will not happen, and here DR and BDR election will happen. That means many of you are thinking that DR and BDR election is depend on types of link, but guys, no. DR and BDR election is depends on types of network, and you know, by default on serial link Ospf network type is point to point. By default on serial link network type is point to point, and by default network type on Ethernet link is broadcast. And in point to point network DR and BDR election will not happen, but in broadcast domain DR and BDR election will happen. So that is the reason why here in this topology DR and BDR election will happen, and here in this topology DR and BDR election will not happen, because here network type is point to point. But as you know, here also DR and BDR is not required because two routers are directly connected. So you should change network type if two routers are directly connected, right? So guys, we will discuss each and everything about these 5 types of network, where you need to configure point to point network, where you need to configure broadcast network, non-broadcast, point to multipoint, each and everything. Okay, but first of all let me design one chart, one table to make you understand some basic thing. Suppose this is my table. Let me again. Okay, here I am going to make you understand something, guys, where DR and BDR and static and dynamic neighborship is supportable. So see, this is, we have one row for some information like types of network, hello time, date time. Hello time and date time also depends on types of network, not on types of link. Okay, so how many types of network we have? 5 types of network. So this is row 1, row 2, row 3, row 4 and row 5. So suppose this is 1 column for types of network. We have 1 column for hello time, we have 1 column for date time, we have 1 column for DR and BDR, we have 1 column for static neighborship and 1 for dynamic neighborship. Okay, so okay, this is network type. Network types. Here we will mention hello time. What will be the hello time in broadcast network, in non-broadcast network, everything. Here we will mention date time. Date time. In this column we will mention DR and BDR, DR or BDR. BDR. Here we will mention a static neighborship, and here we will mention dynamic neighborship. Okay, so first type of network is point to point. Second is broadcast. Third one is non-broadcast. Fourth one is point to multi-point. Fifth one is point to multi-point non-broadcast. Point to multi-point non-broadcast. So guys, in point to point network types, whenever OSPF network type is point to point, then hello time will be what? 10 seconds, and hold on time, date time is 40 seconds. And in point to point network, DR and BDR election will not happen. DR and BDR not required. Static neighborship not so supportable, right? Dynamic neighborship supportable, yes, fine. When network type is point to point, hello time will be 10 seconds, date time will be 40 seconds. DR and BDR is not required. DR and BDR election will not happen. Static neighborship is not supportable, and dynamic neighborship is supportable, right? If network type is broadcast, again hello time will be 10 seconds, date time will be 40 seconds. DR and BDR election will happen. Yes, DR and BDR election will happen. Static neighborship is not supportable, right? Not supportable. And dynamic neighborship, yes, we can configure dynamic neighborship in broadcast network. If network is non-broadcast, then hello time will be 30 seconds. Here hello time will be 30 seconds and hold on time will be 120 seconds. Okay, and DR and BDR can support, yes. DR and BDR election will happen. Here we can configure a static neighborship if my network type is broadcast. So see guys, dynamic neighborship is formed with the help of multicast packet, right? OSPF router send multicast address, multicast hello message. But in non-broadcast network, multicast message are not allowed. So here dynamic neighborship will not support. Dynamic neighborship is not support. You can't configure dynamic neighborship if network type is non-broadcast. You can configure only a static neighborship, or hello time will be 30 seconds and date time will be 120 seconds. Okay, is it clear? Fine. Now if network type is point to multi-point, guys, we will discuss these things when you need to use network type point to multi-point, when you need to use network type non-broadcast, broadcast, and point to multi-point, non-broadcast. This is point to multi-point, non-broadcast. Point to multi-point, non-broadcast. Okay, so after watching this video you will understand each and everything. Don't worry, just wait for some time. If my network type is point to multi-point, we will discuss when we need to configure network type point to multi-point as well. Network type is point to multi-point, then hello time will be 30 seconds, hold on time will be 180 seconds, hold on time will be 120 seconds, and DR BDR election is not happen. DR BDR election will not happen, and you can't configure a static neighborship. Static neighborship is not supportable in point to multi-point network, and a static neighborship is supportable, right? We can configure a static neighborship. Last one, if my network type is point to multi-point non-broadcast, then hello time will be again 30 seconds, hold on time will be 120 seconds, and DR BDR election will not happen. DR BDR election will not happen, and a static neighborship, here you can configure a static neighborship. A static neighborship is supportable in point to multi-point non-broadcast network, but again dynamic neighborship is not supportable, right? We can't configure dynamic neighborship here, not. Okay, so this is chart. You can take a screenshot of this chart, right, where DR and BDR required, where static and dynamic neighborship is supportable. Fine. Now see, in non-broadcast network, right, like this network, in this network, and point to multi-point non-broadcast domain. So whenever network type is non-broadcast, dynamic neighborship will not support, because in broadcast network router can't send multicast address, right? Because multicast address are not allowed in non-broadcast network, right? So there you need to configure a static neighborship only. So you can see in two types of network, when network type is non-broadcast or point to multi-point non-broadcast, in that scenario you have to configure a static neighborship. Fine. Okay, if network type is point to point, then DR and BDR is not required. DR BDR election will not happen. But network type is if point to point, then DR BDR election will not happen. If network type is broadcast, non-broadcast, DR and BDR election will happen, right? But again, if network type is point to point or point to multi-point or point to multi-point non-broadcast, DR BDR election will not happen. Fine. So guys, see, when we need to configure point to point network, when two devices are directly connected, right, the network type should be point to point, and DR BDR is not required here, right? Because both are directly connected. What is the use of DR and BDR? To reduce the number of adjacency, to reduce flooding, right? So if two routers are directly connected, why one router will become DR? So even if you are using Ethernet link or you are using serial link, if two routers are directly connected, your network type should be point to point, right? First of all, let me configure this topology, then we will discuss when we need to configure broadcast network, non-broadcast network, point to multi-point network, and point to multi-point non-broadcast network, right? Let me configure R1 first. config T, interface serial 2/0, say no sut, and IP address. Suppose IP address is 12.1.1.1, 255.255.255.0. Let me configure OSPF. Router OSPF process ID 1, router ID is 1.1.1.1, and network is 12.1.1.0, wildcard mask 0.0.255, and area 0. Fine, OSPF configuration is done. Now you can verify network type on serial link. By default, network type on serial link is point to point. So IP OSPF interface serial 2/0. Here you can see network type is point to point. So by default, network type on serial link is point to point. That means here DR and BDR election will not happen, right? So DR BDR election is not depends on link. DR and BDR election is depends on types of network. Let me configure R2. Config T, interface serial 2/0, say no sut, and IP address. IP address will be 12.1.1.2, 255.255.255.0. Exit router OSPF 1, router ID is 2.2.2.2, and network is 12.1.1.0, wildcard mask 0.0.255, area 0. OSPF configuration is done. So IP OSPF neighbor. So here you can see neighborship is full, but there is no DR and BDR. There is no DR and BDR because of network type. Here I am running OSPF on serial link. So on serial link, OSPF network type is point to point by default. On serial link, by default, OSPF network type is point to point. So IP OSPF interface serial 2/0. There is no DR and BDR. Here you can see state is point to point, and network type is also point to point. So in point to point network, instead of DR BDR, state will be what? Point to point. This is a separate state, that is point to point. So if network type is point to point, DR and BDR election will not happen. And many of you was thinking that DR and BDR election is depends on link, that which type of link we are using. No, DR and BDR election is depends on types of network. Here if I will change the type of network, you can see, go to interface serial 2/0 and IP OSPF network. Let me configure broadcast here, broadcast. Now you can see, so IP OSPF interface serial 2/0. Now network type is what? Broadcast, and state is waiting. After some time, here you will see DR, state will be DR. This router will be elected as DR. State is waiting, right? Till, let me change network type on R2 also. Config T, interface serial 2/0, IP OSPF network type is broadcast. So in broadcast, DR and BDR election will happen, right? So see, this state of this router is DR other, because now here I am running which type of network? Broadcast. But by default, network type on serial link is point to point. So that is the reason why DR and BDR election is not happening. Okay, if you will run so IP OSPF neighbor command, now you can see 2.2.2 is DR. State is not stuck in X start state. It will take some time. Yes, now you can see state is full, and 2.2.2 is DR, and 1.1.1 is, so IP OSPF interface serial 2/0 is BDR, DR other, sorry, BDR. This router will become, yes, definitely one router will become DR and other one will become BDR. There are only two networks, but in this network DR and BDR is not required, right? Because there is only one adjacency, and DR and BDR is used to reduce the number of adjacency, right? So there is only one adjacency, so not require DR and BDR. So we need to change network type. We need to configure point-to-point network here. So interface serial 2/0, serial 2/0. IP OSPF network type is point-to-point. In the same way on router 2 also. Interface serial 2/0. IP OSPF network type point-to-point. So IP OSPF neighbor. So see, there is no DR and BDR now. So DR and BDR election is depends on types of network nodes, depends on type of link. And here on Ethernet link, let me configure OSPF in this topology. Let me configure R3 first. See, config T, interface F0/0, say no set, and IP address. Again, IP address is support 12.1.1.1. Here also 255.255.255.0. Exit router OSPF 1, router ID suppose 1.1.1, and network 12.1.1.0, wildcard mask 0.0.255, and area 0. Here on Ethernet link, you can verify network type. By default, OSPF network type on Ethernet link is broadcast. So IP OSPF interface F0/0. You can see network type is broadcast, and in broadcast network DR BDR election will happen, right? So after some time state will be changed. State of this interface will be DR or BDR. Okay, so go to router number 4 also. Let me configure router 4. Config T, interface F0/0, say no set, and IP address is suppose 12.1.1.2, 255.255.255.0. Exit router OSPF process ID 1 and router ID 2.2.2.2, and network 12.1.1.0, wildcard mask 0.0.255, area 0. So IP OSPF interface F0/0. See, network type is broadcast. Network type is broadcast. So by default, OSPF network type on Ethernet link is broadcast, and in broadcast network DR BDR election will happen. So state is BDR. You can verify. So IP OSPF neighbor. Okay. So but DR BDR is not required here. So what you guys are doing mistake, you guys are configuring priority 0 so that this router will not participate in DR and BDR election. So what will happen if I will set priority 0 here? If I will set priority 0, neighborship will stuck, right? Neighborship, because network type is what? Network type is broadcast. DR and BDR is required. But if you will set priority 0, so no one router will participate in DR and BDR election. So if DR and BDR election will not happen, then neighborship will stuck in which state? In two-way state. Let me configure. Go to router number 3 and say interface F0/0, IP OSPF priority 0. Go to router 4 also, and let me set priority 0 over here. Interface F0/0, IP OSPF priority 0, and see. So IP OSPF neighbor. State is stuck in two-way state. Both router are DR other, but network type is broadcast. So DR and BDR is required, right? So this is problem. But when two routers are directly connected, right, you have to configure network type point to point. Doesn't matter which type of link you are using, right? So first of all, let me remove priority 0 command, interface F0/0, and say no here. No. In the same way on router 3 also, let me say no. Fine. After that, you can change network type. IP OSPF network type is point to point. This is correct way to configure network, to configure OSPF if two routers are directly connected with Ethernet link. Here also IP OSPF network type is point to point. Now you can see. So IP OSPF neighborship is full. There is no DR and BDR. Even I am using Ethernet link. So IP OSPF interface F0/0. You can see on this interface network type is what? Point to point. Okay. So till now we had discussed that when two routers are directly connected, we should use which type of network in OSPF? Point to point, right? We should use point to point network types if two routers are directly connected, right? So this is point to point. So when you will configure point to point network type, when two routers are directly connected. Okay, if more than two routers are directly connected through one switch like this, so here we need to configure network type what? Broadcast, so that one router will become DR. So if physical topology is multi-access, see guys, we have two types of topology, right? We have two types of topology. Let me discuss here. We have two types of topology. First one is full mesh topology, and second one is hub and spoke topology. Suppose this is my router 1, R1, this is R2, this is R3. Suppose this is my main branch hub router, right? Suppose we have 3 branch in an organization, right? Both are connected through ISP. Okay, and if R1 and R2 is directly connected, right, through virtual circuit, if I have created one virtual circuit between R1 and R2 also, between R1 and R3 also, and between R2 and R3 also, then you can see all routers are directly connected with each other. So this is full mesh topology. Full mesh topology, right? When you will take connectivity reachability through ISP, you have to create virtual circuit, right? You have to pay some amount for virtual circuit also. So if all your branch are directly connected through virtual circuit, then network types of topology is full mesh. And we have one more type of topology, that is hub and spoke topology. Suppose this is my R1, R2, R3. Between these branches we have connectivity through ISP. This is my hub router, main branch router, and this is my spoke router, branch office router, spoke 1 and spoke 2. And I have created virtual circuit between R1 and R2 only, and here between R1 and R3 only. We don't have virtual circuit between R1 and R2. R1 and R2. So R2 can communicate with R3 via hub router. R2 cannot communicate with R3 directly, or you can say branch 1 cannot communicate with branch 3 directly. Yes, branch 2 can communicate with branch 3, but via main branch, via hub branch, right? Because we don't have any virtual circuit between branch office. We have virtual circuit between hub and branch office only. Okay, so if my network type is full mesh, अगर मेरा network type क्या है? Full mesh, then you can use these two types of network. Then you will use broadcast and non-broadcast network. If your topology is full mesh, in full mesh topology you will run broadcast network or non-broadcast network. Point-to-point network, when you will configure point-to-point network, when two routers are directly connected. When two routers are directly connected, in that scenario your network type should be point-to-point. If your topology, your network is full mesh topology, then you need to configure broadcast and non-broadcast network, right? But if your topology is hub and spoke, then you need to configure these two types of network, point to multi-point or point to multi-point non-broadcast, if my network is full mesh. So let me design one topology here, and before that let me, okay, so here as you can see in Eve I have created this topology. This is full mesh topology, right? All devices are directly connected with each other. All devices are directly connected with each other. So I am going to configure this network. Here I will configure network. I can configure network type what? Broadcast and non-broadcast. First of all, I will configure network type broadcast. Then I will show you how to configure non-broadcast. When you will configure non-broadcast, you have to configure neighborship static, right? Because in non-broadcast network, dynamic neighborship is not supportable. Okay, so let me take access of router 1. Let me configure this router. So enable config T and host name. Host name is R1. Okay, here I am going to run this IP address 192.168.10.1, and behind router 1 I will create one loopback 1.1.1. behind router 2 I will create loopback 2.2.2, and behind router 3 I will create loopback 3.3.3. okay, so host name of this router is router 1. Let me create one loopback interface loopback 1 and say IP address is 1.1.1.1 255.255.255.0. okay, exit interface F0/0 no sat and IP address. Here I am going to configure IP 192.168.10.1 255.255.255.0. okay, let me configure IP on router 2. Enable config T and host name router 2. Interface loopback 1. IP address is 2.2.2.2 255.255.255.0. exit interface F0/0 say no sat and IP address is 192.168.10.2 255.255.255.0. right? Let me ping router 1 192.168.10.1. you can see I am able to ping router 1. Let me configure router 3 now. Enable config T interface loopback 1. IP address is 3.3.3.3 and subnet mask is 255.255.255.0. exit interface F0/0 say no sat and IP address is 192.168.10.3 255.255.255.0. okay, so this is my full mesh topology. You can see I am able to, let me change host name as well. Config T, host name is R3. Host name is router 3. okay, you can see I am able to ping router 1 as well and router 2 as well. Ping 192.168.10.1. yes, I am able to ping 10.1, ping 10.2. I am able to ping 10.2 also, right? So this is my full mesh topology. Here I am going to configure Ospf. okay, so in full mesh topology network type should be broadcast or non-broadcast, right? Network type will be broadcast and non-broadcast, because here if you will configure network type what? point to multi-point, so there will be some problem. Problem can be what? Problem can be, okay, we will discuss problem later, just wait. Let me configure OSPF first. So go to router number 1 and configure a router OSPF process ID 1 and network. I can run network 0.0.0 command to advertise all active interface in OSPF domain. So network 0.0.0 wildcard mask 255.255.255 and area 0. Right? So by default network type on Ethernet link is broadcast. So IP OSPF interface F 0/0, you can see network type is broadcast. Okay, so in broadcast network DR and BDR election will happen. Yes. Dynamic neighborship is supportable. Yes. Right? So we don't need to configure anything else on router 1. Now let me configure, let me close this access. Okay, now let me configure OSPF on router 2. Config T router OSPF process ID 1 and network is 0.0.0.0 wildcard mask 255.255.255.255 and area is 0. So IP OSPF neighbor. Okay, so neighbor ship with 1.1.1 is full and 1.1.1 is my DR, means router 1 is my DR. Let me configure router 3 OSPF on router 3. Config T router OSPF process ID 1 and network is 0.0.0 wildcard mask 255.255.255.255 and area 0. So IP OSPF neighbor. Right? So there are 2 neighbor of R3. In the same way there will be 2 neighbor of this router also, 2 neighbor of this router also, 2 neighbor of this router also. Right? So guys, first of all understand one thing. Router 3, so IP OSPF neighbor. So 3.3.3 is DR other. Here network type should be broadcast and non-broadcast. Why? Because if you will configure point to multi-point network or point to multi-point non-broadcast network, then DR and BDR election will not happen. Right? So number of adjacency will be 2 on every router. Number of adjacency will be 2 on every router. Now number of adjacency on every router is on router 4. You can see number of, because 2.2.2 is BDR. Let me configure priority 0 on router 2 and router 3 so that BDR, I don't want BDR in this topology. I want only DR because we have only 3 branch. If suppose there are 100 branch, so number of adjacency will be only 2 with DR and BDR. Right? With DR other and DR other, there will be two-way state neighborship. Right? Neighborship without adjacency. There are 2 types of adjacency on OSPF. Right? So here what we need to do, we need to configure priority 0. IP OSPF priority 0. In the same way on router 3 also. Config T interface F 0/0 IP OSPF priority 0. Okay, now you can see, so IP OSPF neighbor. So there is only one adjacency with 1.1.1. With 2.2.2 state is two-way. Right? With DR other and DR other state will be two-way. So if network type is broadcast and non-broadcast, there is no problem. There is no problem. But if network type is point to multi-point or point to multi-point non-broadcast, then there will be no DR and BDR election, right? There will be no DR, there will be no BDR. So every router will form how many adjacency? 2 number of adjacency. So if there will be 100 branch, then every router will form 100 number of adjacency. So this is problem in full mesh topology. So that's why in full mesh topology you can configure broadcast network or non-broadcast network. So if you will configure broadcast network, then static neighborship is not supportable. In this network, static neighborship is not supportable. Now you can't configure static neighborship, right? Dynamic neighborship is supportable and DR and BDR election will happen, right? So now you can see every router, every branch can communicate with each other. So IP root Ospf. So there is 1.1.1 also and 2.2.2 also. I can ping as well, ping 2.2.2.2, right? So if my network type is full mesh topology, in full mesh topology you will configure which type of network? Broadcast, or we can configure non-broadcast as well. If I will configure non-broadcast, then router will not send hello message, because hello message are not allowed in non-broadcast message. Then you have to form a static neighborship. So let me change network type. Go to router number 1, config T, interface F0/0, IP Ospf, network type is non-broadcast. Okay, in the same way go to router 2, IP Ospf, network type non-broadcast, right? And go to router number 3, interface F0/0, IP Ospf, network type non-broadcast. Okay, and let me remove priority 0 command from here, say no. In the same way from R2 also. Say no. Now network type is non-broadcast, so dynamic neighborship is not supportable here. You can see, so IP Ospf neighbor. So IP Ospf neighbor. No one is neighbor. So here we need to configure a static neighborship now. So go to router number 1. See why neighborship is not there? Because router are not sending multicast hello message. Multicast hello message are not allowed in non-broadcast network, right? So you have to configure a static neighborship. So once you will configure a static neighborship on router 1, it will start sending unicast hello message to their neighbor. So you don't need to configure a static neighborship on both sides. Even if you will configure on router 1, neighborship will become up. Okay, let me show you. Go to router number 1 and say router Ospf process ID 1, and your neighbor is 192.168.10.2, right? And so IP Ospf neighbor. So IP Ospf neighbor. Neighborship state is now in attempt. So in Ospf neighborship state we had discussed that there is one more state, that is attempt in case of static neighborship, right? So it will take some time, just wait. Now you can see neighborship is full and 2.2.2 is DR, because router who have highest IP address will become DR. In the same way, router 1 you have to configure one more static neighborship, router Ospf 1, and neighbor is 192.168.10.3. You have to form neighborship between both branch. Okay. So IP Ospf neighbor. State with 3.3.3 is attempt, just wait. So always keep in mind, if my topology is full mesh topology, there you will configure which type of network, broadcast or non-broadcast. If network type is broadcast, then neighborship will be dynamic. If network type is non-broadcast, then neighborship will be static. And in full mesh topology, you can't configure network type point to multi-point, because on point to multi-point there will be no DR and BDR. So if there will be no DR and BDR, number of adjacency will be much. Number of adjacency will be much. So now you can see there are two neighbor of router 1, right, on R3 or on R2. Let me show you. So IP OSPF neighbor. So IP OSPF neighbor. So there is only one neighbor, right? So between branch, between router 2 and router 3, also we have to perform a static neighborship, right? So either you can configure on router 2 or you can configure on router 3. So go to router number 2 and say router OSPF process ID 1, and your neighbor is 192.168.10.3. Sorry, not 32, 10. Let me remove this command. No, 3. So IP OSPF neighbor. Wait. See, there are two neighbor. 1.1.1 is BDR and 3.3.3 is DR. Okay, and so IP root OSPF. See, in the routing table of router 2 there is 3.3 also and 1.1.1 also. So I can ping 3.3.3.3 and source is suppose 2.2.2.2. Yes, I am able to ping. In the same way you can ping 1.1.1 as well. 1.1.1. Okay. So if my topology is full mesh, then we can configure network type, broadcast and non-broadcast. Now if my network is hub and spoke, how I will make this topology as hub and spoke topology? I can stop communication between this port and this port with the help of port security. With the help of port security, I can configure these two ports as protected port, and as you know, two protected port cannot communicate with each other. Two protected port cannot communicate with each other. So my physical topology will be like this. R1 is connected to R2 and R1 is connected to R3, right? There is no connectivity between R2 and R3. So I can configure these two ports as protected port. So first of all, let me show you network type here. So IP OSPF interface F0/0. Here on you can see network type is non-broadcast, and in non-broadcast network, as you know, DR and BDR election will happen, but dynamic neighborship is not supportable, right? So here in this network you have to configure a static neighborship. Okay, now guys, let me do one more thing. So IP OSPF neighbor, who is DR 3.3.3. Let me make this topology as hub and spoke topology. Let me configure switch, and I am going to configure Ethernet 0/1 to 0/2 as protected port. Enable config T interface range E 0/1 to 2 and switch port switch port protected, right? Now you can see here router 2 cannot communicate with router 3. Neighborship is down. Ping 192.168.10.3. I am not able to ping 10. 3, but I can ping 10.1, right? So because there is no any connectivity between router 2 and router 3, and OSPF network type is non-broadcast. Even if you will change network type here, let me change network type on R3. Let me set network type broadcast. IP OSPF network type is, say, broadcast. Okay, and let me copy this command and let me paste on all router. Go to router number 1 also. Interface F0/0. Say network type is broadcast. Let me paste this command on R3 also. Sorry, on R2 also. Interface F0/0. Network type, sorry, IPOSPF network type. Broadcast. Okay, and see. So IPOSPF neighbor is 1.1.1 only. Neighbor is only 1.1.1 because there is no any connectivity between router 2 and router 3. Now even I am running network type broadcast. My LAN which is connected to branch office cannot communicate with the user which is connected in other branch office, because on every router here also you can see. So IP OSPF neighbor. So who is neighbor? Only 1.1.1. So on R1, if you will check neighborship, so IP OSPF neighbor, OSPF neighbor. So neighbor is, router 1 has 2 OSPF neighbor, 2.2.2 and 3.3.3. means my topology is hub and spoke. This is my hub router. Neighborship is there with branch office. Right? But there is no neighborship between branch and branch. Neighborship is there between branch and hub only. There is no neighborship between branch and branch. And this router is DR. Problem is this one. Problem is what? Problem is when my branch office router will become DR, then there is problem. See, my network type is broadcast, so one router will become DR, right? One router will become DR, router whose highest router ID will become DR. So this router is DR, right? This router is DR other, this router is support DR other. So router 3 will share their database with DR only, not with DR other. So how this router can share their database with this router? Because there is no any virtual circuit between router 2 and router 3. Router 2 cannot communicate with router 3 directly. So this is problem. Now my topology is hub and spoke. Here we can't configure broadcast network or multi or non-broadcast network, because if branch office will become DR, then communication will not happen. You can check the routing table of router 3. Go to router number 3 and see. So IP root OSPF. There is no 2.2.2. So branch office can communicate with hub office, no problem, but branch office cannot communicate with other branch office, 2.2.2. Right? In the same way you can verify it on router 2 as well. So IP root OSPF, there is no 1.1.1. There is no any root, by the way. There is no any root, because DR is this router. So DR will share their database with DR other, with router 2. But router 2 is not DR. So why router 2 will share that database with router 2. So suppose this is router 3, this is DR. So DR will share database with, every router will share their database with DR, and DR will share with DR other. So DR router will share database with router 1, but router 1 will never share database with router 2. So this router will never came to know about 1.1.1 network or 3.3.3 network, or about this network as well. So here what we can do, we can configure higher priority here, so that this router will become DR. So if branch router, if hub router will become DR, then there are two neighbor of DR, so it will share their database with this router also and this router also. Am I right? So go to router number 1 and let me set priority. Let me set higher priority here. Config T, interface F0/0, IP Ospf, priority suppose 100, right? So IP Ospf neighbor, clear IP Ospf process, say yes, and so IP Ospf, so IP Ospf neighbor. Let me clear Ospf process on router 3 also. Clear IP Ospf process, say yes, and so IP Ospf neighbor. Now who is DR? 1.1.1 is DR. Now who is DR? 1.1.1, right? Now you can see the database, routing table of router 3. So IP root Ospf, there is no any prefix, right? Go to router number 1, and so IP Ospf neighbor, neighbor is 2.2.2. so here 2.2.2 is DR and 3.3.3 is DR other. So who is DR? 2.2.2. DR is 2.2.2. so IP Ospf neighbor, 1.1.1 is BDR, but priority is 100 here. Priority is 100, so this router should become DR. So this router should become DR. So go to router number 2 and let me clear the process. Clear IP Ospf process and say yes. So IP Ospf neighbor, one dot one will become DR now, right? Okay, now 1.1.1 is DR, and so IP root Ospf, there is no any prefix. So this is problem, because my topology is full mesh, sorry, hub and spoke, and network type is broadcast. So there will be problem, right? If branch office router will become DR, they will not share their database with other branch office router. And now you can see the routing table of router 2. There is no, sorry, there is 1.1.1 and 3.3.3. In the same way, in the routing table of router 3 also, you can see all prefix. 1.1.1 also, 2.2.2 also. But can I ping 2.2.2.2? No. I am not able to ping 2.2.2 because of exit interface. See guys, in the routing table 2.2.2 is available, but next hop is what? 10.2. Next hop is 192.168.10.2. so it will forward traffic to 10.2. It will forward traffic to 10.2. It will go to switch. Switch will out from this interface, but switch can't out from this interface because these two ports are protected. There is no any virtual circuit in real time. In real time you will not create any virtual circuit between branch and between branch office to branch office. So that's the reason LAN user cannot communicate, right? So my topology is hub and spoke. Here we need to configure which type of network, point to multi-point. So go to router number 1 and change network type. Interface F0/0, say IP OSPF, network type point to multi-point. In the same way, go to router number 3 also and let me configure point to multi-point. Interface F0/0, IP OSPF, network type point to multi-point. On R3 also, interface F0/0, IP OSPF, network type point to multi-point. And so IP OSPF neighbor. Now you can see neighbor is 1.1.1. There will be no DR and BDR, right? There will be no DR and BDR in point to multi-point network. So IP root OSPF, there is 2.2.2 and next hop IP is now 10.1. So this branch office can communicate with 2.2.2.2. Yes, you can see. So if my topology is full mesh, then you need to configure which type of network, point to multi-point, right? Otherwise branch office cannot communicate with other branch office. Okay, if it is clear to you, then we have one more types of network, that is point to multi-point non-broadcast, that we can configure in hub and spoke topology. So here we can configure point to multi-point non-broadcast network as well, but then you have to configure static neighborship, right? Why there is no problem now, guys? Because there is no DR and BDR. Because there is no DR and BDR. If in hub and spoke topology DR and BDR election will happen, then there will be problem. So that's the reason why we are not able to configure network type broadcast and non-broadcast in hub and spoke topology. Okay, now let me change area. Let me configure point to multi-point non-broadcast. Then you have to configure neighborship static, network type point to multi-point non-broadcast. Okay, in the same way on router 2 also, point to multi-point non-broadcast. Okay, and in the same way on R3 also, interface F0/0, IP OSPF, network type point to multi-point non-broadcast. Okay, so IP OSPF neighbor. So IP OSPF neighbor. Network type is what? Let me check. So IP OSPF interface F0/0, network type is point to multi-point. So we need to remove this command first, guys. Sorry. Interface F0/0 and say no. IP OSPF network type point to multi-point. Okay, in the same way on router 2 also you have to remove this command, say no. And on R1 also. say no. Now my network type is, so IP OSPF interface F0/0. Network type is broadcast. Let me configure point to multi-point non-broadcast interface F0/0. IP OSPF network type point to multi-point non-broadcast. And if you will verify now, so see now guys, network type is point to multi-point non-broadcast. So IP OSPF neighbor. So output is few difference between real device and on Eve router. Okay, so don't worry, you can see there is no neighborship now, right? On R1, go to router number 2 also and see, so IP OSPF neighbor, there is no any neighbor, right? In the same way on R3 also, so IP OSPF neighbor, there is no neighbor. So now you have to configure neighborship manually, static neighborship. So go to router 3, router OSPF process ID 1 and neighbor is 192.168.10.1. Non-broadcast multi-access network. Okay, so IP OSPF neighbor, right? So we are not able to configure a static neighborship on non-broadcast multi-access network. So let me change network type here. Interface F0/0, IP OSPF network type point to multi-point non-broadcast, and router, now you can see neighborship is full, you can verify it. So IP OSPF neighbor, but there is no DR and BDR. There is no DR and BDR, right? Neighbor is 1.1.1. In the same way, go to router number 2 also, and first of all let me configure network type point to multi-point, IP OSPF network type point to multi-point non-broadcast. So IP OSPF neighbor, neighbor is 1.1.1. These are previous configuration, don't worry about that, this thing guys. Okay, right? So IP root OSPF, you can see there is 3.3.3 also and 1.1.1 also. So can I ping 3.3.3? Yes, I can ping 3.3.3 because exit interface is 10.1 for this network. Okay, so here in hub and spoke topology, you can configure point to multi-point network and point to multi-point non-broadcast network. What is difference between these two types of network? In point to multi-point network, you can't configure a static neighborship. Neighborship will be dynamic, but there will be no DR and BDR. And DR and BDR is not required in hub and spoke topology because every branch office will form neighborship with hub router only, right? So you can see connectivity is like point to point between hub and spoke only. There is no neighborship between branch office to branch office. So DR and BDR is not required. So that's why in hub and spoke topology we will configure point to multi-point network and point to multi-point non-broadcast network. Okay, now if here you will see, if here you will run show IP root command, show IP root, guys, there is 3.3.3 with /32, with /32, but I have advertised 3.3.3 with /24 in OSPF domain. Then why here is 3.3 with /32? Because this is loopback network. So network type on loopback interface is so IP OSPF interface loopback 1. See, on loopback interface network type is loopback. So loopback is also an types of network for loopback interface only. On this interface, whatever IP address you will configure with any prefix length, that prefix length will be considered as 32. And if you want to change network type on loopback interface, see, interface loopback 1, IP OSPF network type is broadcast. See, invalid types of network for invalid types for interface loopback 1. So on loopback interface you can't change network type. So this is separate types of network in OSPF. Okay, so that's all for today, guys. This is network type, these 5 types of network in OSPF. Okay, so and if you will configure virtual link, then network type on virtual link will be virtual link. Virtual link is also an types of network, but these 5 types of network is very important for you. In some video we will discuss these 2 types of network in detail as well. Okay, so here point to point network will be used when 2 routers are directly connected. Broadcast network and non-broadcast network can be configured in full mesh topology, and point to multi-point and point to multi-point non-broadcast network can be configured in hub and spoke topology. Okay, so that's all for today. If you like this video, please hit on like button. If you haven't subscribed my channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. In next video we will discuss types of area in OSPF. Okay, bye bye guys.